Welcome, Hornets, and thank you for joining me today. We are taking a look at assignment number 3, found on page 309, numbers 3 through 13 all, 27 through 45 odds only, then 46, 47, 51, 52, and 53. Now, please be aware I may end up having two parts, and we'll have to see how it goes. So we're going to start with number 3, and number 3 is asking you to work with the integration from 2 to 6 of 8 dx. And the first thing that I have to do is find delta x. This is found by b minus a divided by n. And so we're looking at the gap between the two values, which is 4 over n. We're now going to have to construct our integration, or the limit process summation. That means I'm going to have the limit as n approaches infinity. We're going to put our delta x in front, so that's 4 over n times the summation as I goes from 1 to n, and we're looking at 8x. Now remember, our x is going to be our initial term, in this case 2, plus 4I over n. But because there's no x in the problem, there's nothing for me to replace it with. So we're looking at the limit as n approaches infinity of 4 over n times 8n using our formula for a constant, and our answer turns out to be 32. Going to number 4. Number 4 is asking us to take the integration from negative 2 to 3 of x dx. That means that my delta x is going to be the gap, 5 over n, and my x is going to be negative 2 plus the same 5 over n times I. And this is now what we're going to use to construct. So we have the limit as n approaches infinity. We're going to have 5 over n out in front times the summation, and we're putting negative 2 plus 5I over n, and it is to the first power as I goes from 1 to n. And this is now what we're going to work with. Now, please be aware I like to bring this out in front. So I'm going to have my limit as n approaches infinity for 25 over n squared times the summation of I minus the limit as n approaches infinity, and I now have 10 over n summation of 1. This is giving me 25 over n squared multiplied by n squared over 2, and that allows me to have 25 over 2 minus, and this is giving me 10n times n, and therefore I'm subtracting 10, and my answer is 2.5, or 5 halves. All right, let's go ahead and take a look at number 5 next. Number 5 is where we start to get a little bit more difficult because we're now using the higher powers of I. In this case, we're going to see an I cubed. So we're starting in number 5, working with the summation from negative 1 to 1 of x cubed dx. Start by finding your delta x. Delta x is going to be 2 over n. Then find your x generic. That's going to be our initial term plus 2I over n. This is what we're now going to work with. So we have our limit as n approaches infinity for 2 over n times the summation, I starting at 1 and going to n. And now in place of our x, we put 1 plus 2I over n, the quantity cubed. Now I've already taken the liberty of multiplying this out. I recommend that you take a moment and do that. So put your video on pause and then check to see if you get the same thing. If you don't, you'll want to go back and double check. So I have the summation, I going from 1 to n, and this will turn out to be a negative 1 plus 6I over n minus 12I squared over n squared plus 8I cubed over n cubed. Now, once again, I'm going to work with this piece first. So I have the limit as n is approaching infinity of 16 over n to the fourth summation I cubed. Then I'm going to have minus the limit as n approaches infinity, and I'm now going to have 24 n cubed summation I squared, plus the limit as n approaches infinity, and I'm going to have 12 over n. This is going to now be n squared, summation I, and then minus the limit as n approaches infinity for 2 over n summation 1. Alrighty, now remember, we only want the highest powers of n, so we're looking at the limit as n approaches infinity for 16 over n to the fourth times n to the fourth over 4 minus the limit as n approaches infinity, 24 over n cubed times n cubed over 3 plus the limit as n approaches infinity for 12 over n squared times n squared over 2 minus the limit as n approaches infinity for 2 over n times n. This gives me 4 minus 8 plus 6 minus 2. And when I add it all up, I end up getting 0. So number 5, the answer is 0. Now this is going to continue with numbers 6, 7, and 8. Okay. Then we'll go to number 9, which is now dealing with our norm. So we're now going to see the norm in number 5, or in number 9. And number 9 is now saying the limit as the norm approaches 0, means we have an infinite number of pieces, and those pieces at infinity are all equivalent. We have I going from 1 to n, and I have 3 c sub I plus 10 delta x, and the interval, is -1 to 5. And we're trying to write this as an integration. So we're working our way backward now. So the first thing I want to do is recognize that this is my c sub I. This is the value that's the in-between. And if I were looking at it, the c sub I would have ended up being -1 plus, and then we would have had 6i over n. But they're just using the generic c sub I, so we don't have to worry about that. Life is in general very good here. So all we're going to do is recognize that this is my x, and I'm going from -1 to 5. So the integration, -1 to 5 of 3x plus 10 dx is the answer to number 9. Let's take a look at number 10. Number 10 has the limit as the norm approaches 0. And I have my summation of 6 c sub I, 4 minus c sub I delta x, and this is squared, I equaling 1 to n. The interval that we're looking at is 0 to 4. So the integration from 0 to 4 of 6x times 4 minus x, the quantity squared, dx. And this is my answer. Notice the c sub I is our x. Number 11. Number 11 gives you the norm, or the limit as the norm approaches 0. And we have our summation, square root c sub I squared plus 4 delta x, and the interval is 0 to 3. Integration 0 to 3, square root x squared plus 4 dx is my answer. And there we have number 11. Okay, let's go ahead and take a look then at the next group of problems. I'm going to go ahead and let you do numbers 12 and 13 on your own. And we're looking at number 15. And let's make sure. So I did ask you to skip 15 up to 27. So let's not worry about that. Let's just go to number 27. Beware, all we're doing is approximating or writing down the integration of that. So number 27, which is a little bit more of an important problem, gives us the integration from 0 to 3 of 4 dx, and they want us to now use geometry. So if I have a graph from 0 to 3, and I have y equals 4, the area under the curve is 12, and my answer is 12. 29. Again, we're doing the odds now. So I have the integration from 0 to 4 of x dx, drawing my line from 0 to 4, 0 to 4. I have 1/2 base times height, and that's giving me 1/2 4 times 4, and my answer has to be 8. So 29 is now 8. All righty, continuing on, let's see. Going all the way up to 45, so I'm going to go to the next section. Let's do number 31. Let's just keep going. Make sure that everybody understands how to do these. 0 to 2 for 3x plus 4 dx. Draw it. This is now a trapezoid. We're going from 0 to 2. The first value is at 4. The second value is 10. So now you just have to figure out how you want to do it. If I go over 2, this is going to give me 4 times 2 is 8. And I'm going over 2 and up 6. 12 divided by 2 is 6. And I should end up getting 31 is 14. Once again, just doing areas and drawing and sketching the picture. So sketch the picture and then use geometric symbols or areas in order to find your total. Now, in the next group of problems, they tell you that 2 to 4 of x cubed dx is 60. They tell you that 2 to 4 of x dx is 6. And they tell you that 2 to 4 of dx is 2. And they want you to find in number 37 the integration from 4 to 2 of x dx. Now, this is in the wrong orientation. We have to flip it, and when we flip it, we put a negative. So it's now going negative integration of 2 to 4 of x dx. And we're going to now do a direct substitution with this piece right here. And we end up getting negative 6. So my answer for 37 is negative 36. 39. 39 gives us the integration of 2 to 4 of 8x dx. The constant moves out in front, and we now do the integration for the x dx. By direct substitution, we have 4 times 6, and my answer becomes 48. So I end up having 48 for number 39. go ahead and continue with number 41. 41 gives you the integration, 2 to 4. We have x minus 9 dx. So we're going to separate this so that I have 2 to 4 of x dx minus, and now let's just be careful, the integration. So I have 9 integration 2 to 4 of dx. This right here is a direct substitution with 6, and this is a direct substitution with 2. So I end up with 6 minus 18, and my answer is negative 12. So the answer to number 41 is negative 12. I'm going to leave you to do the remaining in number 43. And I'm going to go ahead and I'm going to move on to number 45. Once again, using properties. So number 45 is asking me to use the properties that 0 to 5 of f of x dx is equal to 10, and the integration from 5 to 7 of f of x dx is equal to 3. So in A, we want the integration from 0 to 7 f of x dx, which has to be the sum of the two parts, 0 to 5 f of x dx plus 5 to 7 f of x dx. Notice how this is structured, because all we're going to do now is put the missing pieces where they are. 10 plus 3, and my answer is 13 for A. Going to B, B is asking me to find 5 to 0. 5 to 0 f of x dx, written inappropriately, becomes negative 0 to 5 f of x dx, and by direct substitution, I end up with negative 10. Going to C. C is 5 to 5. Notice there is no change in the value. Since I have no area of integration, I have no area under the curve, and my answer is 0. D. D is now asking me to do 0 to 5 of 3 f of x dx, and the constant is going to move out in front, 0 to 5 f of x dx. I now do a direct substitution, and I have 3 times 10, and my answer is 30. Alrighty, so we're now going to move to some of those in the back. And if you recall, we were going to be taking a look at numbers 46, 47, 51, 52, and 53. And these are just talking about areas under the curves. So we're following with the same basic process that we did with number 45. So 46 gives me 0 to 3, f of x dx equals 4, and 3 to 6 of f of x dx is equal to negative 1. So if I want 0 to 6, I'm going to take 4 plus negative 1, and I get 3. For B, if I want 6 to 3, it's inappropriately written and will be negative 3 to 6, and that gives me negative of negative 1 for a positive 1. C is 3 to 3, no change, and therefore I get 0. D is now 3 to 6, but it's negative 5. 3 to 6, and that's negative 5 times negative 1, and my answer is 5. You're going to do the same thing with number 47. 51 is now asking you to look at the area using the triangular method. So you're working with geometric shapes, triangles, squares, trapezoids, and rectangles. in order to find your areas. And I'm going to let you go ahead and do those. Please remember, if you have questions, make sure that you come in after school and you ask me in person. Otherwise, thank you very much. And as my lights have gone out, I'm going to stop here with assignment 3. I hope this has helped. Please remember, if you like this or this has helped you, please make sure you click like so that I know that I'm being effective. Otherwise, make sure you put comments on how I can improve. Thank you very much. Please be well, be safe, take care, and remember, it's easy to be mean, so let's try and be kind to each other. Good night, Hornets. Be well and take care.